Good morning, everybody. Today for the CATS math problem, we're going to find the surface area of a rectangular prism. Please note that in my hands I have a tissue box, which is an example of a rectangular prism. What we're going to be looking for exactly is we're going to be unfolding this tissue box, and we've got to find the area of the entire box unfolded. When it's unfolded, it is the net. I'm sure you've heard that word in math class the last few days, but we will be looking for the area of the entire net. So let's take a look at this box. On a rectangular prism, the first thing we want to know is how many sides or faces the box has. So in this case, we have a top and a bottom, which makes it 2. We have a left and a right, which puts us at 4. And then we have a front and a back. So altogether, there are 6 faces of this rectangular prism. So in essence, we're going to be looking for the area of 6 different sides. Okay? So what I'm going to do here, actually the first thing we're going to do is we're going to measure the box. So what I need for you all to do is write down length, width, and height. Okay, I'm going to give you a couple seconds to write down length, width, and height. All right, so the first thing that I'm going to do is I'm going to go ahead and measure the length of this box in centimeters. So right next to your length, please write down 22.5 centimeters. That's the length of the box. The width of the box is going to be 12 centimeters exactly, and then the height of the box is 6 centimeters exactly. So we should have a length of 22.5, a width of 12, and a height of 6. Hope you all got that down. All right, so what I'm going to do now is I'm going to go ahead and unfold this box so we can see what it looks like. And now that it's unfolded, this is what we have. This is the net. A net is a flat pattern that can be folded to create the rectangular prism. So if you notice, earlier we said there were 6 faces of a net, or of a rectangular prism, excuse me. So here's 1, here's 2, here's 3, here's 4, here's 5, and here's 6. Okay? So we're going to be looking for the area of this whole entire thing. All right, I'm going to head to the back of the room. All right, so the first thing that we're going to look at here, okay, this is the 3-dimensional figure of the Kleenex box. Okay, we said that the length was 22.5 centimeters. All right, we said that the width of this box in centimeters was 12 centimeters. And we said that the height here was 6 centimeters. Okay, that's what it looks like 3D. Now if we look at the net, okay, we're going to be looking at something that looks like this. All right, so again, the length is 22.5 centimeters. The width, which would be this side right here, is 12 centimeters. And the height of the box, if you were to fold this up, would be right here, is 6 centimeters. Okay? So what I would like for you guys to do, and teachers, this is where you're going to pause as soon as I give the directive. What I would like for everyone to do is I would like for you to use the knowledge that you have. Area of a rectangle, we have 6 rectangles here, is length times width. I would like for everyone to calculate the surface area of this entire net. Okay, so we're going to give you guys a few minutes to get that done, and you may begin. All right, so let's go ahead and take a look at what we had. Mrs. Alfaro is going to come back to the three-dimensional figure. What I'm going to do is I'm going to start by calculating the front. If you notice here, this is the front of the three-dimensional shape. Now, if I use the formula length times width, the length of this rectangle is 22.5. The width going up here would match this side. If this is 6, this would also be 6. So we should have multiplied 22.5 times 6. All right, so let's see what you got there. 6 times 5 gives you 30. 6 times 2 is 12. 12 plus 3 is 15. 6 times 2 is 12. 12 plus this one is 13. Now notice that we did multiply with decimals. We have one number behind a decimal here all together. So we're going to take our imaginary decimal and move it one time to the right. To the left. Alright, so you got to think of something. If the front is 135 centimeters, then the back of this should also be 135 centimeters to the second power. Alright, now let's look at one of the sides. Okay, let's take this side for example. Okay, using the same formula of length times width, alright, the length of this one right here is 12 and the width is 6. So mental math knows that 12 times 6 is 72. Alright, so coming back over here, what we should know is that if the left is 72, the right should also be 72. Okay, so far we've calculated 4 of the 6 faces. Alright, now we're going to go ahead and we're going to calculate the bottom. Okay, so again, using the formula of length times width, we know that the bottom here, this part right here, we know that the length is 22.5, and we know that the width of the bottom is 12. So now we need to multiply 22.5 times 12. Let me zoom it in a little bit. Alright, so 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4. Moving to the tens place. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. We're going to add these up all together, and we should end up getting 2700. Again, we multiplied with a decimal. There is one number behind the decimal here, none here, for a total of 1. So it looks like the bottom is 270. So coming back to what we have, if the bottom is 270, then the top would also be 270. Now since we're looking for the surface area of the entire shape, I'm hoping that you all recognize that we need to now add all 6 of these numbers together. So let's go ahead and add them up. 5 plus 5 is 10. 10 plus 2 is 12. 12 plus 2 is 14. I see 4 sevens here, so 4 times 7 is 28. 28 plus 3 is 31. 31 plus 3 is 34. 34 plus 1 is 35. And finally we have 2 plus 2, which is 4, plus 1 is 5, plus 1 is 6, plus 3 is 9. Okay, so your surface area of that entire Kleenex box should be 954 centimeters to the second power. I hope that you all got this problem correct. If you didn't get it all correct, hopefully you got some of it correct and do understand what you could have done differently to get the right answer. I wish you all a happy Wednesday and hope you have a great week. Thank you.